Because there is any issue with the internet, then please let me know because currently I'm in hometown, so maybe the internet is fluctuate. So please let me know if there is any network issue. Correct. So I'm not able to turn on the camera. Okay. So my presentation is visible to everyone.
Yes, sir.
Yeah, good. Thank you so much for the confirmation. Uh, so today we are going to start the third unit. Yeah. So today we are going to start the third unit, that is a battery energy storage system, and class number 9. So we already completed the two units. So there is a first unit that is a fundamental of the electric vehicles, and second unit that is like control of the motors. Correct. We have to use the motors. So how we are able to control the electric motors. So in the first and second unit we already completed and we discussed the detail about the vehicles, electric vehicles, IC engines and the motors. In the previous class we discussed the selection of the electric motors for the EV application and control strategies of the electric motors. So as I said in the last class, control strategy of the electric motors, that is also separate subjects, and it will take around like one semester to understand the how we can control the induction motor, PMSA motor, BLDC motor, SRM motor. So in this subject just I cover the overview of the control strategy of the motor. Correct. So maybe you can read the more books. Yeah, maybe you can search on the internet for the detailed analysis of the controlling part. Correct. So any confusion, any query from the previous class? So there is a selection of the electric motors. So major parameters. So there is a power rating, torque rating, and the speed of the vehicle. Then we can decide the which type of motor we have to use. Correct? Maybe the induction motor, maybe the PMSM, maybe the BLDC motor. Correct? If no confusion, then we can start with the third unit. So today we are going to discuss the introduction of the battery. So what is a battery? And then various types of batteries parameter. So we have to know the which type of parameters importance to analysis the battery performance, and finally equivalent electrical circuit of the battery. So today we are going to discuss the like overview of the battery. So maybe you know about the some terminology about the battery, maybe you forgot about the terminology. So today we are discussing about the fundamental of the battery. So what is a battery, what is a cell? Okay. So, starting with the introduction of battery, so simple batteries are widely used as a source of the direct current, electric energy in the automobile, boats, aircraft, ship, portable. So everywhere, 90% devices we are using the battery, correct? So you can start from the mobile, even laptop, even small gadget, correct? So everywhere we are using the battery. In some instant, they are used as a only source of the power, and while in others they are used as a secondary or the standby power source. Okay. A battery consists of the number of cells. So that is a battery is not a single components. So we can make the battery by combination of the cells, and that is a series and parallel combination of the cells. Then we can say now we have a battery. Correct. Cells assemble in the common container and connected together to the function as a source of the electric power. So we have to connect the series and parallel cell. So we can say this is the cell, single cell, then another cell. So we have to connect in the series, and then we can say this is the positive terminal and this is the negative terminal. Correct. So we can say this is the cell number 1, this is the cell number 2. Correct. So what is a cell and how we can make the battery? Correct. So that we are going to discuss in the today's class. So in the 11th and 12th standard, we already studied this battery concept in the physics subject, correct? So maybe the some of the student is studied in the 12th, maybe the before the like 20 years back, correct? Maybe the some student maybe already studied maybe the before the 15 years back, correct? So maybe you forgot the concept of the battery. So I start with the fundamental of batteries. What is a battery? A cell is a device that transforms the chemical energy into the electrical energy. So this is a simple fundamental concept because we cannot generate the energy, we cannot destroy the energy. We can only convert the energy from one form to another form, correct? So in the battery, we can convert the chemical energy into the electrical energy. There is a fundamental concept. So how we are able to convert the chemical energy into the electrical energy, that concept we have to study. A simplest cell known as either the galvanic or voltaic cell. So we can say the photovoltaic cell. Okay. So simple cell, there is a galvanic cell, otherwise the photovoltaic, otherwise the voltaic cell, not the photovoltaic. Is a simple voltaic, otherwise galvanic cell. So what you are able to see, so this is the negative terminal and this is the positive terminal. Otherwise we can say anode and the cathode. Normally we can say anode and cathode, otherwise normally we can say the positive terminal and negative terminal. In between we have to connect the load, so you can say this is the load. This is the load, and load may be the any type of load, correct? And since positive and negative terminal, that is a depend on the material, maybe the lithium ion cell, maybe the lead acid battery. So that is a depend on the battery, which type of battery. So normally negative terminal, that is a design by the graphites. So material is a graphite, correct? So normally we can use the negative terminal by material of the graphite, and positive terminal by material of the maybe the lithium ion cell, then it is a lithium, maybe the lead acid battery, then lead. So depend on the type of battery we can choose, there is a positive terminal. And negative terminal, 99% case, mostly we can use the graphites. Okay. And this is the this it is a, yeah, we can say the electrolysis. It is a electrolysis, there is a chemical, correct? By chemical reaction we can produce the electricity, correct? So you can see some negative terminal here, some positive terminal here, and there is a flow of the charge, correct? And then it is a generate the energy. So it consists of the piece of the carbon, there is a C, and the piece of the zinc suspended in the jar. So there is a one, we can say the one jar, and we can put the positive and negative terminal together and separate by the isolation, correct? That contain the solution of the water, that is a H2O, and sulfuric acid, that is a H2SO4, called the electrolyte. So by processing of the electrolyte, we can generate the electrical energy. Okay. The cell is a fundamental unit of the battery. Yes, without cell we can not make the battery. A simple cell consists of the two electrodes placed in this container that hold electrolyte. Correct. So what is the electrolyte? We have to understand. Correct. So electrodes, what is electrodes? So we have a positive and negative terminal. So electrodes are conductor. Electrodes are the conductor by which current leaves or return to the electrolyte. So maybe we can say the positive, maybe we can say the negative. So you can see this is the negative terminal and this is your positive terminal. Okay. In the simple cell, they are carbon and zinc strip that are placed in the electrolyte, while in the dry cell, is shown in the figure 2, they are the carbon rod in the center and the zinc container in the cell of the assemble. Correct? So we can say in normally we cannot use the chemical. Like in the A4 cell, we can use in the remote as well as the charger. So that is a simple like A4 cell, correct? So that is a not like chemical. But in the vehicle we can use the H2O, that is a chemical part, correct? So for the electrolyte process. Okay, so this is the figure 2. There is a dry cell cross section view, correct? So there is a positive terminal and the negative terminal. Selling wax, zinc container and the negative electrode, wet paste, electrolyte, carbon rod or the positive electrode. Okay, so this is the your cross section view of the dry cell. Electrolyte is a solution that acts upon the electrode. Electrolyte which provides the path from the flow of the electrons, maybe the salt, an acid or alkaline solution. In the simple galvanic cell, electrolyte is a liquid form. In the dry cell, electrolyte is a paste. Correct? As I said, like in A4 cell, we have a like dry cell. Correct? Container is nothing but there is a body. Container which made the construction of the one of the many different material provides the means of holding the electrode. Correct? So we have to hold the both material, there is positive terminal and negative terminal. Okay. Container is also used to mount the electrons. In the volatile cell, container must be the constructed of the material that will not be accepted upon the electrolyte. So there is a simple, we can say the body. Okay, so we can hold the positive and negative electrode. Okay, so what are the cathode and anode? So there is a, we have to understand the cathode and anode because that is a fundamental of the battery. Because battery only two terminal, there is a positive and negative, and one terminal we can say anode, and one terminal we can say the cathode. Cathode and anode are the basic term of the electrochemistry that are used to denote the two positive and negative part of the any electrochemical cell or the battery. Correct? So there is a anode and cathode. So cathode definition, what is the meaning of cathode? In the electrochemical cell, such as the battery electrolyte light cell, cathode is the electrode where reduction or the gain of the electrons occur. Okay. So normally we can say cathode there is your positive polarity and anode there is a negative terminal. And sometimes we can say in the another way anode it is a positive and cathode is a negative. But in the standard definition, electrode where reduction, otherwise the gain of the electrons occur, that is your cathode. Now what is the anode? It is a electrochemical cell. The anode is the electron where oxidation, otherwise the loss of the electron occurs, that is your anode. Okay, so there is a loss of electron, that is your, we can say the anode, and gain of the electrons, that is a, we can say the cathode. Okay, in the case of the battery. So charges on the cathode and anodes. Yes. So what type of charge is available on the anode and cathode terminal? So cathode is associated with the positive charge and undergoes the reduction. Okay. There is a reduction and oxidation. There is a two term in the battery. One is a reduction and one is the oxidation. So cathode is associated with the positive charge and undergoes reduction. Anode is associated with the negative charge and undergoes the oxidation. So that's why I said cathode is always positive and anode is a negative, correct? But sometimes people say cathode is a negative and anode is positive. Okay, but simply you can say cathode that is a reduction process and anode that is a oxidation process. So you can see in the figure, this figure, anode there is a negative terminal, cathode there is a positive terminal, and we can connect the like load in between the positive and negative, and we have a for us this, so there is a isolation between the both terminal, there is a positive terminal and negative terminal, otherwise suppose we cannot give the separation, then it is a short circuited. Okay, so comparison between the anode and cathode. So here is a definition, spelling mistake. So there is a definition. Electrode where the reduction, there is a gain of the electrons occur, and anode that is a electrons flow into the cathode from the external circuit. Electrons are released from the anode into the external circuit. Charge accumulation, accumulated the positive charge, accumulated the negative charge. Okay, so cathode there is a positive charge, and anode that is your negative charge. Function in the cell, consume the electrons during the spontaneous electrochemical reaction, produce the electron during the spontaneous electrochemical reaction. Direction of the current flow. What is the direction of the current flow in the cathode? From cathode to anode. So we can say the positive to negative, and always current is flowing from the positive to negative. And anode from anode to cathode. Example, in the battery, cathode is where reduction occur during the discharge. Yes, in the case of the battery, we can say discharging process, then we can say it's a reduction, and charging process, then we can say the gain of the electron. In the battery, the anode is where oxidation occur during the discharging. Okay, so this is a simple comparison between the anode and cathode uh, terminals.
Sir,
Yes.
how to current flow from cathode to anode in anode from anode to cathode?
Can you just repeat your question? How to?
Sir, go to the previous slide. Sir.
Yes,
In
yes.
cathode, current is flow from cathode to anode. In anode, then there is from anode to cathode. How to, sir?
Yeah, there is a like rechargeable battery. So when you can say the rechargeable battery, so suppose there is only one time uses and primary battery, then there is a not possible. But if it is a rechargeable battery, then it is a possible. So we have a two type battery. One is a primary battery and another one is a secondary battery. So primary battery that is a not rechargeable. We cannot recharge that battery. But secondary battery that is a rechargeable battery. While rechargeable battery that is a possible anode to cathode. The flow of the anode to cathode. Got it?
Okay, sir.
Yeah, still confusion. Okay. Yeah. Any more confusion? Any more question? Okay. So this is a simple example. We already discussed there is a anode, negative terminal, cathode, positive terminal. Electrolyte. So what is a electrolyte? A medium, usually liquid, gel or solid that facilitate the movement of the ion between the anode and cathode. So that is a electrolyte. So we have to use the electrolyte. So this is the your electrolyte. So this material that is a electrolyte, and this material may be the liquid, maybe the gel, maybe the solid. Okay, any material. Separator. So separator is what? So we have to separate this anode and cathode, correct? So this separate. Suppose you are not put the separator, then it's a short circuit. So separator is what? A porous membrane that physically separate the anode and cathode to prevent the direct contact while allowing the ionic conductivity. Correct? Ultimately, there is a chemical reaction. Suppose you are not put the separation, and suppose you are not put the membrane, then it is a short circuited. Okay. Yeah. So you can see this is the lamp, and there is a connected between the positive and negative, and that is your lamp is glow. Okay. Yes. So this is the fundamental of the battery. So how batteries work and which type of material we have to use, and major components. There is a anode, cathode, separator, and electrolyte. Okay. Now we are going next topic. There is a important technologies of the battery. So we have around like 10 technologies for the battery, understanding of the battery, and we have to understand the how we can charge the battery, how we can discharge the battery. So that concept we can start from here. Okay. So battery capacity, maybe the all student know about the battery capacity. Writing is a ampere hour, otherwise the milliampere hour. Correct. So there is a battery capacity. So first terminology, battery capacity. It indicates the total charge of the battery can store. So how much energy we can store in the battery, that is your battery capacity. This will express in the terms of the ampere hours. There is a H. A indicate the ampere and H indicate the hours. For example, suppose battery is a 100 ampere hours can deliver the 100 ampere for 1 hour. So suppose your battery rating is a 100 ampere hours, then we can say for 1 hour we can take the current there is a 100 ampere. So this is the fundamental terminology of the battery, correct? There is a battery capacity. Next terminology, there is a energy capacity. So what is a energy? It tells us total energy a battery can store and deliver over the time. So energy is nothing but work, correct? So how much work we can do for the particular time period. So that is a nothing but your energy, correct? So energy can be energy a battery can store and deliver over the time. It's often expressed in the watt hour. Energy capacity, that is a watt hour, is equal to voltage into capacity. So voltage into capacity, capacity is what? Ampere hour. So for example, if a battery has a voltage of 12 volt and charge capacity is 100 ampere hours, then we can say energy capacity, that is a 12 into 100. So we can say energy capacity is a 12 volt into 100, that's a 1200 watt hour, correct? So for the we can connect any load, so we can take 1200 volt per hour, that is the energy capacity. Energy density. Energy density, battery energy density measure energy stored by mass and volume. So how much energy we can store for particular battery? Suppose we have a simple A4 cell, then how much energy we can store, correct? For the particular mass, otherwise particular volume. The average unit used are watt hours per kilogram. So this is the density. So we can say watt hour per kilogram. Energy density help to assess the how long the battery can hold the charge based on it is a size. Correct? So how much energy we can store. Otherwise, how much energy it is a hold, that we can find out by the energy density. Okay. Next, power density. It is defined as the maximum power output of the battery, maximum power output of the battery, expressed in the watt per kilogram. So power density unit is a watt per kilogram. This power density define how quickly energy supplied to the consumer can meet it is a needs to opposed to energy store defined by the energy density. So this all the definition most important. I will ask in the exam, as well as this definition will use to design your project. Maybe suppose you are working on the battery management system, then this definition will useful. Correct? Internal resistor. So it is the resistance the battery offers against the current flowing through it. So there is an internal resistance. Yes, every components have an internal resistor. The resistor may be attributed to the chemical process and the physical property of the various components of the battery, like electrolyte, electrodes, and the internal connection. And unit of the internal resistor, there is a ohm. Okay. Voltage. A battery chemistry determine the nominal voltage. So we can say the nominal voltage. For example, lithium ion cell operate at minimum 3.7 volt nominal voltage. Okay. So and for the every cell it is a different voltage. So there is a nominal voltage rating for the every cell, otherwise every battery. Okay. State of the charge. So we can say the SOC. It is a measure current charge level of the battery compared to it is a maximum capacity. It is indicate how much energy is left in the battery is a given time. So maybe the 100% charge available, maybe the 80%, maybe the 50%. Similarly to the fuel gauge in the car. SOC is a term in the percentage. We can say the 100%. So normally we can say our mobile battery is 50% charge and 50% discharge. Correct? Maybe the 10% charge and 90% discharge, such as the 100%, which means fully charged, and 0%, which means completely discharged. So there is a SOC. Depth of discharge just opposite of the SOC. It is indicate how much of the battery capacity has been used to relative to its total capacity. It is also expressed as a percentage like 0% depth of discharge, which means no energy has been withdrawn. That is a fully charged. So just it is opposite of the SOC. Okay, so 0% depth of discharge means 100% charge. The relationship between the SOC and SOC is 100% minus depth of discharge. Okay, so we can say the 50% depth of discharge, it means our battery is a 50% charge and 50% discharge. Cycle life, it is indicate the number of charges discharge cycle up to the specific level. So we can say we can charge the battery maybe the 100 time, we can discharge the battery that is 100 time. Okay, so generally 80% of the original capacity of the battery can go through, while lead acid battery could last up the 500 cycle and lithium ion one could the 2000 cycle. So that's why normally we can use the lithium ion battery in the electric vehicle as well as the mobile as well as the laptop. Correct. So because life cycle of the battery it is a more. So you can see lead acid battery we can get only 500 cycles, so we can use only 500 times, and then we have to replace with another battery. Okay, and then we have to destroy all the battery. There is a life cycle, otherwise the cycle life. Charging and discharging rate. So one of the student asked me, so how much current it is required to charge our battery? So that is a depend on the charging and discharging rate, and that is a C rate. So C rate is the most important to decide the charging current and discharging current. So in the next class, yeah, maybe the next to next class, we will take the example. So how much battery current is required to charge our battery? Okay. So as of now, we can understand the charging and discharging rate, and that is a C rate. Def- Define the speed at which the battery charge or discharge. For example, 1C rate, there is a 1C rate, the battery will charge or discharge in the 1 hour. So 1C means that is a battery charge and discharge for the 1 hour. For example, a 10 ampere hour battery discharge at 10 ampere will take the 1 hour. Suppose you take the like 10 ampere current, so it will take the 1 hour charge. Correct? So it will take the 1 hour time period. High C rate capability is desired for the fast charge. So maybe the 2C, 3C, 4C. Correct? But again, there is a issue with the battery life. Okay. So yes, technology is going on. So maybe the higher C rate we will get the battery, but again there is a issue with the battery life. Okay, that is a charging rate.
Sir,
Yes.
sir, what is the difference between ampere hour and watt hour efficiency? Can we convert watt hour into ampere hour or ampere hour into watt hour?
Yeah. So ampere hour and watt hour, correct? So ampere hour there is a battery capacity. In energy capacity there is a watt hour. So your question is, can we convert the watt hour into the ampere hour and vice versa? Correct? Correct. That is your question.
Yes, sir. Yes, sir.
Yeah, you can convert, no issue. So suppose you know the voltage rating, then you can easily convert, not an issue. Because we know the power, correct? So power is nothing but P equal to VI, and this is the DC quantity. So power is nothing but P equal to V into I. Cos theta is not there because this is a DC quantity. So suppose you know the voltage and current, both the quantity. So we can easily convert into the watt hour and the ampere hour. So it is simple to convert the like vice versa. Maybe the ampere hour to the watt hour. Yeah, watt hour to the ampere hour. That is simple. We can convert.
So excuse me.
Yes.
So suppose a battery charging and we have to
Can you, yeah,
calculate.
speak loudly? Can you speak loudly?
So
Yes. Yes.
if I
Yes.
suppose the battery is under state of charge, then what is the logic behind the calculation of state of charge of a battery?
So battery is 100% charge. Then what is the logic of?
No, sir. Battery. No, sir. I am
Mm-hmm.
charging the battery in
Mm-hmm.
the present state, and I want to
Mm-hmm.
calculate the state of charge in every instant of time. Then what is the exact logic of calculation of state of charge of the battery?
So for the every instant you want to see the SOC
Yes, sir.
while charging the battery.
Yes, sir. Yes, sir.
Ah, as of now, I don't know. So, what is the logic we have to use? So, that is a battery management system. So, that is a part of the battery management system. But as of now, I don't have any answer for this because you want the every instant, correct? And
Yes, sir.
this is what we.
In BMS, when we see
Uh-huh.
the lithium-ion battery inside the lithium-ion battery, we see the state
Yes.
of charge is blinking from 0 to 1, 2, 3, 4, according to the design. So
Mm-hmm.
it's goes continuously like it is 10% charge, and later it's increases and it reaches 100%, like just like in our mobile. So what
Yes.
is the
Yes. Yes.
logic behind the calculation of that state of charge and displaying to the user? What is the exact logic?
Yeah, so how they are measuring the state of
Yes,
charge
sir.
for the every time, correct? So maybe
Every
the
instant of
suppose
time,
we
yes, sir.
yes, suppose we can charge our mobile for 5 minutes, and suppose that is a charge for 5 minutes, maybe the 2% or 3%. Then how they are
Yes, sir.
measure the like 2% and 3% charge, correct? So I got it, but as of now, I don't have any answer because I don't want to tell you the wrong answer. Correct? I don't want to misguide you. So I will find out the answer. So which type of control approach they are used. So because every instant they are sending the data for the mobile. So now your battery is 10% charge, now 20%, now your 100% mobile charge. Correct? So which type of parameter they are measuring and then saying the like your battery is 100% charge, yeah, 20% charge. So as of now, I don't have an answer. So which type of topology, yeah, which type of control approach they are using, correct? But I will find out and then let you know in the next class. Is it okay?
Okay, sir.
Yeah, and meanwhile, you can please send me the message, correct? Because as of now, I am in the home, so maybe I forget it. So please send me the message, correct? So I remember this question. Okay,
Okay, sir.
okay. So I will try to give the answer in the next class. Otherwise, suppose I will get the answer before the next class, then I will send you the answer in the WhatsApp. Okay. Yes. Any other question? Okay.
Okay, okay. Sir, if the C rate of battery is 2C, then how much time it will take full charge, sir?
30 minutes.
40 minutes.
Yeah, C rate is more than it is take the fast charging. But again, suppose you are charged the fast, then battery life is a reduce. So nowadays there is a hot topic is how we can charge our battery very fast and we can increase the life of the battery also. That is a current research because nobody want to stop the like maybe the 2 hours, 3 hours to charge our vehicle, correct? So you can see to charge your battery vehicle, maybe we have to take like 5 hours, 6 hours, correct? But in the people don't want to stop like wait like 2 hours, 3 hours, 4 hours. So people want like very fast charging, maybe the 5 minutes, maybe the 10 minutes, correct? But suppose you charge your battery vehicle very fast, then maybe the life of the battery is reduced. Okay, and that is a current hot topic. How we can increase the life of the battery and while the fast charging. Yes.
What is
Any
trickle
yes.
charging and constant current and constant voltage charging?
Yeah, that we will discuss in the charging method. So coulomb counting method, various topologies are there for the charging of the battery. That we will see in the next to next class.
Sir,
So
Kalman,
yes,
Kalman techniques are for charge state finding state of charge.
extended to Kalman filter. You are
Yes,
saying
sir.
yes, yes, that is possible. But that is a depend on the which type of battery, what is the power rating of the battery, sorry, what is the current rating of the battery? uh, because extended Kalman filter, there is some disadvantage and some advantage, so you have to analysis the another method also. So Coulomb counting method, there is a simple method to charge your battery, correct? And there is a fundamental charging method. So we will see the different charging topologies also. So which charging method we have to charge, we have to use to charge our battery. We will see that also. And suppose you are doing the project on that particular topic, then I will also share the research paper for you, correct? So you will get the like idea, so which type of method we have to use to charge the battery. Okay.
Sir, how many
Okay, sir.
electrodes are there in cell, sir?
Many. So that depend on the battery. So there is a 1 ampere hours, 2 ampere hours. So what is the
No, no,
rating
sir.
of the battery?
Electrode.
Electrode, there is a
How?
one only.
One only.
There is a positive
Is
and
it
negative.
possible, sir, to use more than one electrode in a battery, in a cell?
In one cell, only one electrode. There is a positive electrode and another one is a negative electrode.
If we
There is
put
a one.
more electrode, then it will
No,
require a shorter time
no.
to
As per
charge.
my
And
knowledge, as per my knowledge, we can only use the two electrode. There is a one is a positive and another one is a negative per cell. We cannot use the multiple electrode, as per my knowledge. So you got somewhere. You have any idea? So is there any available the cell with multiple electrode?
For the higher capacity battery, sir, we might need to use multiple electrode
No, we
for
can
the higher
connect in the
capacity.
series, correct? We can connect in the series cell.
We connect series to increase the voltage, sir, but to increase the capacity.
Increase the
during
capacity.
charging, if we use more electrode, then it will take short time to charge, sir. But during discharge, we only use one cell, one electrode for the fast charging. It
I
is
am not.
possible or not, sir?
I am not sure about this, because then electrode. Suppose you are saying that for the fast charging, we can put like one positive electrode and another one is negative, correct? So, and we can use like multiple electrode at a time. Then how you are synchronize that cell? How you can synchronize that electrode?
That is for lithium ion batteries, sir. We connect small cells into series and parallel connection.
Mm-hmm.
Uh, but for VRLA battery, sir, lead acid battery,
Uh huh.
higher capacity, we use multiple electrodes.
Are you sure?
We have seen some batteries in telecom, sir, with multiple electrodes.
I have to
So
check it.
since we charge battery in
Which type of
DC
electrodes?
current, so it is possible, sir. Maybe
I have to check it because I am not sure. So multiple
because
electrode.
there is a
It is.
separator, sir, which will separate them positive and negative electrode, and there is
Yeah, that I
not
understood.
possible to
Separator.
short circuit.
Yeah,
Need
separator is possible, but how you
need
synchronize? Synchronization.
Sir,
Yes.
synchronization with what, sir?
So you have a different electron, correct? So one by one
Yes,
you
sir.
are charging. Yeah, all the cell you are parallelly charging. So
Hold
suppose
the
you have
cell
a.
parallelly charging, sir. That
If it
is
is
like
connected
a
in series
single.
parallel configuration, then the current will flow. The flow of current can charge the battery according to the connection series and parallel.
I have to check it because as of now, I don't
This will
have
be in
a.
one completely.
Yes, so maybe there is a possible. You saying that is in the telecommunication company, so maybe there is a possible, but as of now, I cannot say anything. Yes, yeah, no. I have to check it. So there is a multiple electrode are possible, yeah, no. Correct.
So for my understanding, electrode means plus minus zero like that inside of one cell.
There is a positive terminal and negative terminal.
Then there must be two electrodes.
Yes. So you can see there is a positive.
Then, if we
Positive.
say that there are multiple electrodes, then what will be the third terminal? It is
Sorry.
positive, negative, or what?
So multiple terminal, it means there is a positive, positive is multiple and negative is also multiple. That's why
Okay,
I'm
okay.
saying. So suppose it's a multiple, then how we can synchronize the both for the positive as well as the negative. So that's why I'm confusing. Suppose you are saying multiple electrons are possible, correct? In the per
Sir,
cell.
in my understanding, multiple electrodes are used because if the current capacity increases, then a single electrode cannot handle the large amount of currents, and then we have to insert multiple electrodes so that the small sized electrode can handle current
But we can
as a
increase the number
single
of cell,
battery
correct? But we
as
can
well.
increase the number of cell instead of the electron.
Electrode means tapping from different cells.
Sorry. Can you repeat? Electron means.
Electrode means tappings from different cells or cell combinations.
So we have a positive terminal and negative terminal. There is a positive terminal and negative terminal. Both are the electrode, correct? So suppose just 1 minute. So somewhere is maybe the yes. Suppose you have a one cell. So this is the cell one. So this is the your positive terminal and this is your negative terminal. So this is the cell 1, correct? And now we are discussing multiple electrode are possible. So here electron is two only. One is a this positive electron and another one is a negative electron. So now we are discussing there is a multiple electrodes are possible in the cell. So for my understanding, we cannot use the multiple electron in the per cell, correct? Because suppose you are using the multiple electron, suppose here is negative, this is a negative, this is a negative, this is a negative, here is positive, correct? Then how you are charging the positive, how you can charge the all the electron similar, correct? There is a my confusion. But as per your knowledge, maybe you seen in the telecommunication company, yeah, maybe in the industry, maybe possible. Then my question is how we can synchronize this terminal and this terminal, because all the cells are connected in the series with a series and parallel combination. So there is cell 1 similar with the cell 2. So this is the cell 2. Here is a cell 3 similar to the cell 4, correct? And all the cell is connected in the series and parallel with respect to maybe the voltage and current, correct?
No, sir, I'm just telling that if we use more electrode, then
Uh-huh.
there will be more what reactions, and this will produce more electrons
Yeah, so more we have a
during
current
charging.
capacity.
During
Yeah,
charging,
then more we have
but
a.
during discharging, we just use only one electrode. If
Yeah.
we make more charge, then it will charge fast.
Mhm.
This is my
So, what
concept.
about the EV batteries, sir? How they are connected? What is the value of the cell? It is 2 volt or it is larger?
No, there is a like lithium ion battery, there is a 3.7. Here I mentioned in the PPT. Somewhere I mentioned the PPT lithium ion cell 3.7 volt. Lithium ion cell operate at the 3.7 nominal voltage. So one cell is a 3.7 volt,
Hmm.
correct? So suppose your battery rating is a maybe 40 ampere hour, correct? Maybe your vehicle battery volt there is a 40 ampere hour, correct? So now in our lab, in my lab, there is a BLDC motor, and there is a 600 volt, correct? And that is operated by the 40 ampere hours. So that is a depend on the rating of the battery and depend on the how many number of cells connected. So you can see, suppose one cell is a 3.7 volt, correct? And then we can easily find out the ampere hours.
Hmm.
Okay. So that is a depend on the battery rating. So normally two-wheeler, that is a use the 40 ampere hours in the two-wheeler battery, correct? Two-wheeler, and in the 100 ampere, normally four-wheeler battery, four-wheeler vehicle. Normally 100 ampere hours we can use the four-wheeler vehicle, and 40 ampere hour normally we use the two-wheeler as well as the three-wheeler, e-rickshaw and the bike.
So
Then
the 40 ampere hour, 100 ampere hour are the values of cell or as a whole battery?
no, total battery rating, not the cell. Cell is like milliampere hours. It is a not ampere hour. Cell is it is not possible in the ampere hour. It is like milliampere hour. So we
So
have to
in
connect.
Kathmandu, we have different types of auto rickshaws which work on
Yes. So for
electric
this,
vehicles, and I have
I
seen
yes,
that they
yes,
use eight number of batteries. Each battery are 100 ampere hours. So I
yes.
think as a total, it is 800 ampere hour battery
So you can see
they are
here.
connected.
Yeah. So you can see here. This is a cell one. This is a cell two, cell three, cell four, this cell five. All the cells are connected in series and parallel combination. So 8 parallel cell and 13 series cell. And then we can make the battery pack of 48 volt and 20 ampere hours. So this combination, 8 parallel cell and 13 series cell, we can make the battery pack 48 volt and 20 ampere hours. So this is the real scenario in the electric vehicle battery. So this cell I implemented in the MATLAB Simulink library and published the research paper. And this is a fundamental concept. So we will discuss this thing in the today's class. Got it?
Okay, sir. Okay.
Yeah, still confusion. So we will discuss today in this class. So how we can select the parallel and series combination for the battery. So how many cells we have to connect in the series? How many cells we have to connect to parallel? Correct. For the electrode, multiple electron, I have to check it. Correct. So is it possible for the one cell we can use the multiple electron? Correct. If you seen, then maybe the possible, but as per my knowledge, I cannot see the multiple electrode for the single cell. Okay. Done. Yes. Good. Very good. Any more confusion? As of now, any more confusion? So two question is pending. One is first one is I think ampere hours. What is the question? What was the question? First one, I forget it. So please message me. Correct. So that question.
SOC, sir. SOC. How to
Yeah.
calculate
How we
SOC
can
from
how we can calculate the
SOC while
SOC?
charging?
Yes, while charging instant. Correct. Please message me. Otherwise, I will forget. And second one is that it's a multiple electron is possible in the single cell. Correct. This one is the second question. Okay. Yes, good. Any other confusion? Any other query? Okay. Yeah. So lithium ion battery that is like 3.7 volt and maximum voltage is a 4.2 volt. Okay. And that is for different battery. That is a different voltage. Okay. Yeah. So suppose it's a 48 volt nominal voltage battery containing approximately 13 cell in series. Okay. Suppose you have a 48 volt nominal voltage battery. That is a nominal battery voltage. Correct. It is not the cell voltage. It is a 48 volt nominal battery contain approximately 13 cell. So we have a 13 cell. So we will get the 48 volt. So how many cells we have to connect it in the series? So 48 volt divided by 3.7. Why 3.7? Because we are discussing the lithium ion battery. Okay. Lithium ion battery. Because lithium ion battery nominal voltage per cell that is a 33.7 volt. So we have a 40 volt, 48 volt battery. So how many cells we have to connect in the series? So 48 divided by 3.7. So we have to connect the 13 cell in the series. Okay. Then the fully charged voltage and the cutoff voltage becomes 13 into 4.2, because 13 cell and 4.2 is equal to 54.6 volt. Okay, and 13.3 is equal to 39 uh, uh, 39 voltage, that is a cutoff respectively. Okay, that is a charge voltage and cutoff voltage. Okay, take the 1865 cell type. Okay, which has significantly 3.7 volt nominal voltage and 2.5 ampere hours capacity. Then to achieve the 20 ampere hours, so we can say 20 divided by 2.5 ampere capacity. So 2.5 ampere capacity. So we have a total capacity is 20 is equal to 8, which means 8 cell connected in the parallel. So we have to connect the series as well as the parallel. So while connecting the series, we can increase the voltage rating, and connect in the parallel, we can say the increase the current rating. So we can say that 8 cells we have to connect in the parallel. Total number of cell, so cell in the series and cell in the parallel. So we can say 13 cell in the series. So from this data, and 8 cell in the parallel from this data. So we can say total 104 cell we have to connect, and then we can make the one battery pack. Okay. So battery pack will have the configuration of the 13S8P. Suppose battery pack name written on the nameplate 13S8P. So 13S means 13 cell series, and 8P 8 cell parallel. Correct? So this is a meaning of the battery cell. So suppose you have any battery, A4 battery. Otherwise, maybe you can check on the electric vehicle battery. So this configuration you will get it. So 13S, 8P, maybe the any number. So there is a S indicate the series and P indicate the parallel. So 13 cell in series to achieve the 48 volt, and 8 cell is parallel to achieve the 20 ampere hours. Okay. So this design you will get. So this design you will get, and this is a total battery pack. So we can say it is a battery pack. Okay, and we have to analysis, we have to calculate the every parameter for this battery pack, and there is a major issue. Otherwise, we can say the major role for the electric vehicle. How many cell we have to connect in the series and the parallel, so we can effectively get the battery voltage as well as the current rating. Okay. Yes. Any confusion for this topology? Otherwise, we can say the battery pack. Any confusion? We will do numerical also for the different battery rating. So how many cell we have to connect series and parallel to achieve the 20 ampere hours, maybe the 40 ampere hours. Correct. We will do numerical, so you will get the better understanding. Otherwise you will get the better knowledge. Okay. Yeah. So charging current. So maybe the student asked the question, so how much charging current it is required. So maybe he will get idea. So charging currents should be the control to avoid the overheating and damage in the battery. Because ultimately in the battery there is a chemical. Suppose you will charge the like for higher current, so maybe the overheating, correct? The C rate often limit the charging current. So based on the C rate, in every battery manufacturing given the C rate of the battery, correct, which multiply the battery rated capacity. Lithium ion generally safe charge vary from 0.5 C to the 1 C. So zero point 0.9 C is considered in this simulation, that is charging the current. So suppose there is a 20 ampere hours battery capacity. In the previous slide we seen there is a 20 ampere hours capacity, and charging rate is maybe the zero point 0.9 C. Suppose battery company manufacturing decided there is a zero point 0.9 C. It means we have to charge the current that is at 18 ampere hours. So we have to constantly charge your battery 18 ampere hours. That is a constant current. How we can find out? There is a point 0.9, there is a C rate, and battery rating, there is a 20 ampere. So we have to give the charging current, that is a 18 ampere. For lithium ion, the safe and standard discharge rate is 0.43478 C. Correct? The discharge current is 0.43748 into 20, there is a 8.695 ampere. So we have to connect the load across the battery where they can discharge and they can take the current, there is a 8.6 ampere. Then we can say maximum efficiency we will get from the battery. Okay, so this current you have to continue give the your charger to charge your battery, and this current we have to connect our load so they can get, so they can take the current 8.6 ampere constantly. Correct? So maybe uh, uh, student asked the question how much current is required to charge our battery. So that is a depend on the C rate of the battery. So first we have to understand what is the C rate of the battery and what is the rating of the battery. So maybe the 20 ampere hours, maybe the like 40 ampere hours. Then we can easily find out the how much current we have to supply to battery to supply to charger with the battery.
Yes.
Right, to charge our battery.
Sir, we C rate is we assume the C rate or we calculate the C rate, sir?
No. So C rate is provided by the manufacturer, battery manufacturer, and it is a mention on the nameplate.
How,
Nameplate, otherwise the data set.
sir,
Yes.
how the manufacturers calculate or define the C in the battery?
Yeah. So there is a R&D department. So while design the like cell, one cell, so multiple time they are charge the battery and multiple time they are discharge the battery, and they note down the time period. After the note down, and they will get the data, and then they will decide the C rating. So there is a based on the like R&D work, and there is a based on the like, there is a very different company to company also. So suppose I am a manufacturing of the battery, correct, and my in my industry R&D department is there, and they are making the cell, one cell, and they will charge the one cell for particular time period, and then they will discharge that particular cell, and they will note down the time period, and then they will decide the C rate. And that is like multiple time they have to do the analysis. Then they will say it is a 1C, 2C, 3C, yeah, what. It is a not like easy process. It is a very complicated process to decide the C rate also. And as a customer we cannot decide the C rate, because that C rate is given by the manufacturer of the battery. Got it?
Yes, sir.
Yes. Any other confusion? Any other query? Yeah. So who asked me this question? So how much current is required? So student is present in the today's class.
Yes, sir. Yes, sir.
So Bim, you asked.
No, sir. Gan, sir. Gan.
Gyan. So now you got it. Now you got it. So how much current is required to charge our battery?
Yes, sir.
Correct.
But there is, but
Yes.
how to calculate the C rate?
Yeah, C rate I told you na. So that is a like in the industry while design the cell, that time they charge and discharge the battery, and they note down the reading. So for the particular 1 hour, so it will full charge. Particular maybe the point, particular maybe 30 minutes they charge discharge. So they make the like list, charging time and discharging time, and then they will decide the C rate.
Sir,
Otherwise what I can do it, maybe the I will give the process, maybe the I will make in the one, yeah, two slide for the decide the C rate, then I will give the like step by step process, so how they can decide the C rate in the industry.
okay, sir.
Okay. Yeah, any more confusion, any more doubts?
Sir,
I,
here we calculate 18 amperes current for charging. Yeah. And if we
uh-huh.
divide this 18 ampere into 9 ampere and use two electrode, then it will
Uh,
avoid overheating also.
that is
So
again depend. That is
yeah,
again depend on the battery material.
oh, battery material will also affect the
Yes,
this.
obvious, obvious,
Yeah,
because that is a chemical, correct?
yes, sir.
Battery is nothing but chemical. So which type of chemical, electrolysis chemical you use? So suppose you 18 ampere to you want to reduce the 50%, correct?
Yes,
Correct. So again, directly that is a proportional to your battery material.
yes, sir. Because current is directly proportional to heating, I
Yes,
square
yes,
R.
yes,
So if
yes,
we
yes.
reduce the current, and heating will also reduce.
Yes, then it will take too much time to charge your battery.
This will also affect charging
Yeah,
time.
and nobody want to wait, correct? So suppose an 18 ampere, it will take maybe the 1 hour, correct, to charge your battery. And suppose you
Yes, sir.
reduce the 18 hours to the 9 ampere directly 50%. So now you have to wait 2 hours to charge your battery,
Yes,
correct?
sir.
Yeah, so that is nobody want to wait for 2 hours.
Okay,
Okay.
sir. Understood.
Yeah. Okay. Now type of the battery. Uh, yes. Type of the batteries. So many type of batteries available in the market. So batteries are broadly classified two category. One is a rechargeable battery and one is a chemical compositions. Rechargeable batteries means we can recharge the battery, and normally we can use nowadays that is a rechargeable battery, not the like primary side battery. Primary battery, there is a non-rechargeable battery. These are the used ones and disgrade. They provided the power until their chemical energy exuded. Correct. So one time we can use and then we can throw. That is your primary battery, and we can say non-rechargeable battery. But nowadays in the market, normally non-rechargeable battery is very less. Normally people want to buy the chargeable battery. Okay. So types of the rechargeable battery, there is a alkaline, zinc, carbon, lithium, and silver oxide. So these are the like we can say the primary battery. So key features: long shelf life and low cost, because there is a not rechargeable, there is a low cost. Common use, there is a TV remote, clock, toys. Even nowadays everybody use the like rechargeable battery. Zinc carbon, inexpensive, low energy, radio, flex light people use. Lithium ion battery, lithium battery, lightweight and high energy density. We can use the camera, smokes detector. Silver oxide, that is a compact, high energy for the small size. We can use in the watch and hearing aids. Correct. So these are the primary battery we can use. What about the secondary battery? And that is a rechargeable battery. This can be recharged and reused the multiple times and common in the EV, phone, laptop, and everywhere nowadays we use the like rechargeable battery. Lithium ion battery. So nowadays 99% case we can use the lithium ion battery in the EV. High energy density, lightweight, fast charging. Electric vehicle, phone, laptop, everywhere we are using the like lithium ion battery. Nickel metal hybrid. So NIMH still people are not used in the commercial application, but it is on the research work. This is a durable and moderate energy hybrid car. There is a Toyota Pursuit. So recently used the Toyota. There is a nickel metal hybrid battery. Lead acid battery no more use. Heavy, low cost, high current output. Inverter, UPS, e-rickshaw. Normally people use, but after the lithium ion battery, lead acid is outdated. Lithium polymer battery, flexible and lightweight. Drone, tablet, smartphone normally use the lithium polymer battery. Because lithium ion battery, there is a subcategory also. So we will see the in the next slide subcategory of the lithium battery. Uh, Advanced or emerging battery. These are the next generation technology under the development for the better performance. Solid state battery, lithium sulfate battery, and metal Al battery and sodium ion battery. So this whole type of battery, no, it is a not used in the commercial still now. It is only on research work. So solid state battery use the solid electrolyte and safer status in research. Lithium sulfate, lightweight, high capacity, early development. So still it is on research work. Matter air, use air as a cathode. Example Zn air, that is experimental. So now again there is a research work. Sodium ion, alternative to the lithium, cheaper, growing interest. So maybe the after the lithium ion, maybe the sodium ion is the next generation for the battery. Okay, so maybe we can replace the lithium ion battery with the sodium ion as well as the solid state. And these are the like advanced emerging battery technology. Okay, so suppose you are interested on the battery, then you can maybe take the solid state battery, but it is a not like related to our electrical engineering work. It is a totally chemical and chemistry area. Yeah, so you can see the different type of battery. So lithium ion battery, NIMH, lead acid, solid state, sodium ion, and ultra capacitor. So anode material and cathode material. So we have to see the anode material and cathode material, electrolyte process and electrochemical process. Okay, so you can go through this table. So suppose lithium ion battery use the lithium ions as a charge carriers. Anode material generally graphites. Cathode material, that is LiCOO2, otherwise the NMC. This is a chemical component. Electrolyte, which type of electrolyte use? There is a LiPF6 organic solvent. So that's why I said, so design the battery, there is a totally chemical and chemistry people. It is not related to electrical. Electrochemical process, there is a redox with a lithium plus ion intercalculation. Correct? So this is the different type of batteries and different type of materials where we can use the anode as well as the cathode and electrolytes and the electrochemicals. Correct? Yeah. So here is the technical specification. So suppose lead acid battery, nickel cadmium battery, NIMH battery, lithium ion battery, and lithium phosphorus battery. Cutoff voltage per cell for lithium ion there is a 1.75, nickel cadmium 0.9 to 1.05, NIMH 1, lithium ion there is a 3, lithium phosphorus there is a 3. That is a cutoff voltage per cell. I am telling the per cell. Okay. Nominal voltage per cell for the lithium ion battery there is a 3.6 to 3.7. Fully charged voltage per cell for the lithium ion there is a 4.2. Commercialization year, when it is inverted and when it is used commercialized, from 1991 there is a lithium ion battery. Specific energy density watt hour per kg, there is 100 to 265. Energy density watt hour per liter, there is a 250 to 730. Specific power watt per kilogram, that is a 250 to 340. And operating temperature range minus 20 to 60 degree. So suppose you put your battery in the like very cold area, yeah, high temperature, again there is a decrease the efficiency of the battery. Okay, suppose you want to put your batteries very cold area, maybe the minus 30 degree, minus 40 degree, then your efficiency is not, maybe the efficiency is very less, maybe the battery is not working. Okay, so that's why we have to check where we have to operate the battery, in which environment condition. Okay. Yes, so these are the for the particular different type of lithium ion battery. So you can see the LCO, there is a lithium cobalt oxide. LNO, there is a lithium nickel oxide. So all are the lithium ion battery, but subcategory. LMO, lithium manganese oxide. LFT, lithium iron phosphate, and LTO, lithium titanate. So normally people use the LFT for the electric vehicle battery, lithium iron phosphate, because the higher power density, energy density. That's why people use, because you can see the lithium phosphorus battery, this table. Discharge rates 10 and 2000 to 7000 and 2730. So normally people use the LFT. Yes, that is a depend on company to company because price is vary. So these are the just for your knowledge. So we have a like total 5 type of lithium ion battery, and that is a subcategory. Yeah. So equivalent circuit. Yes, I will cover the equivalent circuit. Then we will stop the class. Yes. So equivalent circuit, there is a open circuit voltage. So this is your open circuit voltage, internal resistor, load resistor, and finally this is the load. So you can connect the, any type of load. Okay. So open circuit voltage is what? This is the ideal voltage of the battery when no current is drawn. So normally we can say the circuit is open, then we can say open circuit voltage. Internal resistor. Every real battery has some internal resistor due to the electrochemical reaction and resistor of the electrode and the electrolyte. Yes, for the every material we have a every material has an internal resistor, correct? This resistor causes the voltage drop inside the battery when the current flow. So internal equivalent circuit of battery is very simple. We can say the one is a battery open circuit voltage, one is the internal resistor, one is a load resistor, and another one is a terminal voltage. So how much terminal voltage we will get? So external load, there is a RL. This is the device or circuit connected to the battery. Example, the motor, load, LED, phone. So it is ultimately load. Which type of load we are connecting? It drawn the current from the battery. Terminal voltage, this is the actual voltage available across the load. So suppose you are connecting the motor across the battery, then how much voltage we are getting across the motor? That is your terminal voltage. It is the less than the open circuit voltage due to the internal resistor losses. Obvious. Battery voltage equation. Terminal voltage is equal to open circuit voltage minus I into R internal resistor. So I, there is a current, V output, V naught, there is an internal open circuit voltage, Ri, that is your internal resistor. Okay. So this is your terminal voltage. This much voltage we will get from the battery. So this is my last slide. So we can say the first order, second order, third order equivalent circuit. So this is the first order equivalent circuit. So why we can say the first order? Because we can connect the R and C component in the series with the equivalent circuit of the battery. So this is the open circuit voltage, this is the internal resistor, and this is your terminal voltage. So in between we are connecting the R1 and C1 because we have to store the charge, correct? So we can say capacitor and resistor both are used to store the charge. The equivalent model is used to simulate the voltage as a cell terminal when the electric current is applied to discharge or recharge the battery, correct? The most common represent the consist of the three element in the series. Variable voltage, this is the voltage. Open circuit is a represent the open circuit voltage. Second one is a resistor. So this one is R not resistor, there is an internal resistor. And third one, there is a parallel combination of the resistor and capacitor accounting for the dynamic voltage drop. That's why we can say we are connecting in the parallel R and C, and that is a connected with the series, and that's why we can say it is a first order equivalent circuit. Otherwise we can say the lump model. Okay. So main, we can say this one is equivalent circuit for the battery, and this one for the first order equivalent circuit for the battery. So key point from the today's class, there is an introduction of the battery, various type of battery parameter and equivalent electrical circuit. From the next class, we are going to discuss the functionality of the BMS. So it is the most important component, battery pack sensing, current, voltage, and temperature. How we can sense the voltage, current, and temperature, and then we can discuss the isolation and thermal control. So how we can provide the isolation and how we are controlling the temperature. Okay, and this all are the under the BMS, that is a battery management system. So thank you so much. And these are the references. So I will share the research paper with you. So comprehensive overview of the electric vehicle batteries. There is a market. So which type of battery use? So there is a 2023 research paper. Comparison of battery use in the electric vehicle, 2022 paper. Review of the cell level battery, there is a 2024, and lithium ion phosphate battery recycling. So how we can recycle the battery, there is a 2020 paper. So I will share this research paper, so you will get the more idea about the battery. Okay. Yes, thank you so much for your attention. If you have any confusion, then please let me know. Otherwise, today I am happy because you asked the many questions in the today's class. I am very very happy in the today's class. Yes.
Sir,
Any more confusion? Yes.
for lithium ion battery, fully charged voltage is 4.3 volt, 4.2 volt. Yes, sir.
Per cell.
Person then fully charged means SOC is 100%. Yes, sir.
SOC is 100. Yes.
If cut-off voltage is 1.3, for cut-off voltage, how much the SOC, sir? There is any value, sir?
For cutoff voltage, SOC value.
Yes, sir. For cut-off voltage and nominal voltage.
Uh, Suppose that is your SOC. Suppose that is a 50% your battery is discharged. Then we can set the 50% SOC.
Yes, sir.
And suppose there is like 30% SOC level, then we can say there is a 30% your battery is 70% battery is discharged and 30% charge is available. So for the every cell, they drawn the like 30% charge. Only sorry, for the every cell they drawn the like 70% charge, only 30% charge is available. So you can see suppose 3.7 per cell. So you can calculate the 3.7 for the 70%. So how much value?
3.7.
Got it? Got
No,
it,
sir.
Gyan?
No, sir.
Suppose one cell is a 3.7 volt, correct?
Yes, sir.
For the fully charged. Correct? So fully charged means we can say the 100% SOC level.
Yes, sir.
For the every cell have a 3.7 volt and there is a 100%. Okay. Now your battery is a 50% discharge. So every cell is a 50% discharge. So full percent there is a 3.7 volt. Now 50% discharge. So there is around like 1.7 volt. So every cell have a 1.7 volt. Correct? For SOC of the 50%. Now your SOC is maybe the 30%. It means you have a 30% energy store. 70% you already consume. Correct? So you can easily find out for the 50% around 1.7 volt. Now 30% how much voltage per cell?
1.11.
Yeah, 1.11 there is a per cell voltage. Got it?
Yes, sir.
Yeah, so we can easily calculate. That is like simple, straightforward. For the 100% this much voltage, so 70% how much voltage? Maybe the 30% how much voltage per cell? Yes. Any more confusion? Any more query? So Gyan, you are doing the research on the battery management system. Yeah, maybe you are working in the like BMS related company.
Is related to battery systems, sir. Battery depth of
Sir,
discharge, life cycle of battery.
Yeah, good, good.
sir,
Yes.
sir, can we say that the range of voltage is directly proportional, or we can interpolate with the direct unitary method for calculation of SOC?
Can we say? Can you repeat your question?
I want to say that if you say that 4.2 is 100%,
Uh huh.
and if we want to say what it will be the SOC at 2 volt,
Uh huh.
then is it correct that we should use unitary methods to calculate the SOC?
Yes, suppose you know the per cell voltage, then we can say, suppose you have a sufficient knowledge about the per cell voltage as well as how many cell is connected in the series and parallel. We can easily find out.
So it can also be true that the graph between the SOC and the voltage may not be linear. It
Yes,
can be, yes, sir,
yes,
may not be linear. So
yes, yes.
we cannot say that the percentage and the relationship between the percentage and the voltage is always linear.
Obvious, because there is like internal register. Suppose you are considering the internal register, then we can say it is a linear. And that internal register, there is a depend on the temperature. And temperature is a directly relation on the charging current. Suppose you are considering this all the parameter. One is the internal register of the per cell, another one is a charging current, how much charging current you are giving to the per cell, then you can find out. But normally for the SOC level, we cannot calculate the internal register of the per cell.
So it is true for every mathematical calculations, or
No,
it is just a tentative value.
it is a tentative value. Suppose you are considering this factor, this parameter, then we can say it is a true. Otherwise, it is a approximate value. Because
Okay.
battery, that is a depend on the internal register as well as the chemical component, correct?
Yes, sir.
And whenever temperature is increased, then register is also temperature dependent. We can say register is a temperature dependent, correct?
Mhm.
If register is increased, then we will get the less current,
Okay, sir.
correct? Yes. Yes, any other query, other question? Okay, good. So mostly next month we will meet. So I am planning to visit on the 22nd July. So let's see. Everything is fine. Then maybe we will meet on the 23rd July. Correct. For the next class, I will let you know. Maybe on the Monday I will take, no. Okay. But meanwhile, you can do the simulation also. Okay. So meanwhile, you can complete the simulation. If you have any query about the simulation, then please let me know.